Okay, welcome back everyone to Green Dolphin Science. For this deep dive, we're heading beneath the waves into the Baltic Sea.
Yeah, and what we're looking at down there is, well, it's a hidden threat, a really significant one.
Absolutely. It's a legacy from past wars, but it's not just history. We're talking about huge amounts of dumped conventional munitions.
Things that were just left on the seabed.
Exactly. And this stuff, it's actively impacting life today. You know, everything from the fish people eat to big offshore construction, even the health of the sea itself. We've been digging into a really fascinating research paper that maps this all out, especially focusing on Polish waters, but it applies across the Baltic.
It really highlights the scale. We're not talking about a few stray bombs here and there. It's vast quantities.
So our mission today is to unpack that. What is actually down there? How much? How is it still a danger decades later?
And importantly, what's being done about it? Because finding and dealing with this stuff is a huge challenge.
Yeah, get ready for some surprising details, like just how much is still potentially active and where it's concentrated. It's pretty eye-opening.
Well, the issue really started getting serious attention back in the 80s.
Right, because people couldn't avoid it anymore?
Pretty much. Fishermen especially started pulling dangerous things up in their nets. The paper points out these encounters are actually quite frequent, particularly in the southern and western Baltic.
And the source makes a key distinction, doesn't it, between different types of danger?
Yes, exactly. You've got discarded military material, or DMM. That might be stuff dumped on purpose, maybe unfused.
Okay.
But then you have UXO, unexploded ordnance, stuff used in combat that just failed.
Yeah.
Still fused, potentially very dangerous.
And the numbers involved are just staggering.
Oh, absolutely overwhelming. Estimates suggest something like 360,000 to 385,000 tons of munitions overall dumped in the Baltic.
Wow.
And over 300,000 tons of that is thought to be conventional ammo. Now, what's interesting is, chemical weapons often got dumped way out in deep trenches.
Right, further away.
But conventional munitions often ended up in much shallower water, sometimes surprisingly close to coastlines. Think places like the Bay of Mecklenburg or areas right off the Polish coast.
That closeness is key, isn't it? It puts this danger right in the middle of human activity.
Precisely. The paper lists some major things at risk. Critical shipping lanes for trade, huge infrastructure projects like LNG terminals, for natural gas, pipelines, power cables, offshore wind farms.
So big energy and communication links.
Yeah, and even major naval bases. NATO bases like Gdynia and Świnoujście in Poland are mentioned.
And it goes beyond just the big strategic stuff, too.
Oh, definitely. It affects everyday life.
Yeah.
Fishing boats, people out sailing for fun, tourists on the beaches. The risk isn't just theoretical. It's about direct, possibly catastrophic contact.
The paper gave that chilling example, the Dutch fishing boat Martin Jacob.
Yes, back in 2005 in the North Sea, but highly relevant. They hauled up an old air bomb. It exploded on deck.
Terrible. 3 crew members died, right?
Tragically, yes. And that one incident caused a massive spike in reported findings afterwards. It was a real wake-up call about how dangerous this legacy is.
And that brings up another point from the source, underreporting.
Exactly. A fisherman might find something dangerous. What do? Reporting it means lost time, lost income. There's often no compensation.
So they might just toss it back.
Understandably, yes.
Yeah.
Divers, too, might have reasons not to report. But the result is we lose that specific location data. It makes it harder for everyone else to avoid later.
So these hidden hazards are affecting everything from national security and trade all the way down to individual safety and jobs. But what about the environment itself?
That's another huge concern. These conventional munitions, they're packed with toxic stuff. Heavy metals, obviously,
Yeah.
but also explosive compounds like TNT, HND.
Okay.
And here's a striking point from the research.
Yeah.
The estimated total amount of these toxic substances from conventional munitions in the Baltic. It's thought to be an order of magnitude larger than from all the chemical weapons dumped there.
Wait, really? That seems counterintuitive. You'd think chemical weapons would be the main toxic threat.
It's the sheer volume. There's just so much more conventional ordnance down there. Now, the specific long-term effects of these particular compounds are still being studied, especially compared to chemical agents.
Right.
But research projects mentioned, like UDEM, they have found these toxic compounds in marine life near the dump sites.
So it's getting into the food chain.
It seems likely. Things like TNT metabolites showing up in organisms. That raises obvious concerns for humans eating seafood from those areas.
And then there's the white phosphorus problem. We hear about that washing ashore sometimes.
Yes, definitely. Especially on Polish, German, Latvian coasts. It looks like amber, tragically.
But it's incredibly dangerous, ignites in air.
Exactly. Causes severe burns if someone picks it up. And it's highly toxic. A direct, immediate danger to beachgoers.
So the munitions themselves are toxic, leaking over time. But the paper also mentions something else. Even dealing with them can be risky for the environment.
That's the paradox. The main way to neutralize them is often to detonate them in place. But that creates huge underwater shock waves.
Lethal to marine life, I imagine.
Very much so, especially marine mammals. That's why they use protocols like small precursor charges, sort of a warning shot to scare animals away before the main blast. But it's still a damaging process.
Okay, let's shift a bit. The source material had some mind-boggling stats, specifically about sea mines left over from the World Wars.
Maybe 165,000 to 180,000 sea mines laid in the Baltic.
That's a lot of mines.
It is. And here's the kicker. How many are still there? Estimates for the percentage not cleared vary wildly. Some say maybe 10%. Others suggest 35%, maybe even up to 80% in certain specific zones.
Wow. So do the math. That could be anywhere from, 16,000 up to maybe 60,000 mines still on the seabed, possibly more?
Exactly. It's a huge range of uncertainty, but even the low end is a massive number of dangerous objects.
And they weren't just scattered randomly, were they? The paper mentioned specific hotspots.
Correct. Intensely mined areas like the Gulf of Finland, Gulf of Riga, the Skagerrak, Kattegat, the Central Baltic, and in Polish waters, the Gulf of Gdańsk, and that critical shipping channel to Gestian and Świnoujście were heavily mined, often defensive barriers or to block ports.
The paper also touched on how different areas have different types of ordnance based on past activity, like the torpedoes near Gdynia.
Right. The Gulf of Gdańsk had that big German torpedo research and testing site, Torpedowaffenplatz Hexengrund. They ran thousands of trials.
And lost a lot of torpedoes in the process, presumably.
Many were lost or failed. So you find clusters of torpedoes specifically in that area today. The seabed tells a story.
It really does. History literally lying on the seafloor. But what state are these things in after, 70, 80, even 100 years underwater? Does corrosion eventually make them safe?
That's the tricky part. Not necessarily. So many things. What the casing is made of, how it was packed. Sometimes artillery shells were sealed in waterproof tubes, which helps preserve them.
Right.
What kind of seabed it landed on? Mud, sand, rock.
Okay.
And then the water itself. Oxygen levels, salinity, temperature. Generally, shallower, warmer, more oxygenated coastal waters mean faster corrosion, especially with waves stirring things up. But it's rarely even.
So some might be falling apart, leaking contents, while others are basically intact.
Precisely. The sources say some metal casings are almost gone, leaving the explosive fill exposed. But, and this is crucial, items buried in low-oxygen mud can be remarkably well preserved.
Like time capsules.
Almost. They found artillery shells in the Gulf of Gdańsk after 70 years still in their tubes that were surprisingly active. Same for some mines and torpedoes found buried in sediment, much better shape than similar ones exposed to open water. It's a real mixed bag.
And the danger isn't just the explosives, right? What about the fuses?
That's a major concern. Modern non-contact fuses might fail because their batteries die. But older, simpler mechanical fuses, like those chemical Hertz horn, they could potentially stay dangerous for centuries.
Centuries. Wow. So a bump from a fishing net or even survey gear
Could still trigger a detonation if the casing is corroded, but the mechanism is intact. It's happened. Swedish authorities found contact mines decades later that were still buoyant and considered combat ready.
And things getting covered in marine growth makes it even harder.
Yeah, they lose their distinct shapes on sonar, get mistaken for rocks or debris. Increases the risk of accidental contact because you don't realize what you're bumping into.
Okay, so given this massive scale, the unpredictable condition, the ongoing danger, how are people actually dealing with it today? What's the process?
Well, traditionally, naval mine hunting is a step-by-step thing. First, detection. Find something suspicious on the seabed, usually with sonar. Second, classification look at the sonar image. Does it look like ordnance? Third, identification. Get a closer look, maybe with cameras. Figure out exactly what it is. Neutralization. Make it safe. Usually means destroying it carefully in place. Naval forces, like Polish Navy units and international NATO groups, do this routinely.
And the paper really highlighted how new technology is changing this game.
Hugely. Autonomous underwater vehicles, AUVs, and remotely operated vehicles, ROVs, are revolutionizing mine countermeasures.
How so? Faster, safer.
Both. Compared to ship-mounted sonars and relying on divers, these autonomous systems are way faster and more effective. AUVs can cover huge areas on their own. dive deep, use advanced sensors for much better detection and ID, even on corroded stuff.
So it's a big leap forward in just finding things accurately.
A massive leap. The paper mentioned Polish forces seeing a threefold increase in performance using these systems. Plus, you can deploy multiple vehicles at once, surveying different areas or investigating multiple targets simultaneously.
But it's still incredibly expensive work, isn't it?
Oh, extremely. The source gave an example. Just one Polish unit's routine patrols cost around 60,000 euros for several years in the late 90s, early 2000s. In dealing with a major find, like a huge bomb near a port entrance, that requires massive, complex, very costly operations.
Which is where international cooperation comes in.
Absolutely essential. Groups like the Baltic Ordnance Safety Board, BOSB, help coordinate between countries. They identify priority areas for searching based on shipping traffic, known dumping grounds, water depth, all that intelligence.
And they run joint exercises.
Yes, like Open Spirit. These exercises show just how much is still down there. One in 2018 found 74 dangerous objects, including 52 sea mines, in just a short period. It really underscores the need to work together.
So wrapping this up, this deep dive really hammered home the sheer scale of conventional munitions in the Baltic, hundreds of thousands of tons.
And the fact that it's an ongoing threat, it's not just history. It impacts shipping, fishing, energy projects, and the marine environment itself through those slow-leaking toxins.
It makes it so clear that finding and neutralizing all this is incredibly complex, it's expensive, and it's going to take a very, very long time.
Decades, probably centuries. The progress with tech like AUVs is vital, and so is that international cooperation, but the volume of material is just immense.
Yeah, this isn't some niche historical problem. It affects current economic life, ecological health, future plans right across the Baltic region. Understanding these hidden risks, it feels vital for anyone who uses the sea or just cares about its future.
Exactly. These mapping and cataloging efforts, like the one in the paper, are crucial. They make the invisible visible, which is the first step.
So here's a final thought for you to ponder after all this. We know these munitions are corroding, slowly breaking down. They could potentially release more toxic material over time. How is this underwater risk going to change in the coming decades? And are we collectively really ready for the very long-term consequences of this legacy on the Baltic Sea floor?